Hey everybody, this is Karl. We don't have school today. It's a snow day, and it's looking a little bit crazy outside my window, but it's not too crazy. Anyway, that cuts us down to just 2 days this week, so I know we're not going to get to some of the material at the end of the slides, for instance, especially not if we're going to take time to talk about how to solve the project and work through problems and things. So I wanted to just accomplish some of those things in this optional video. So first of all, this video is not mandatory. It's not necessarily material that you're going to get tested over, but it is, I think talking through this particular problem might help you understand the material better. So we're going to talk about turtles. So we're going to talk about functions today, and we're going to talk about a little bit of problem solving. So if you want help with any of those things, and functions are our thing this week, and turtles are our project this week, then I hope that you'll find this video useful. And if you don't, then skip it. Anyway, so again, this week we'll do all the slides in class. We're not going to skip anything that's necessary and mandatory. But our stuff this week is modules and functions. Some cool stuff that we're going to cover. We're going to cover random numbers. We'll talk about how to generate those and what a computer does. And we'll also talk about the math module, which has some interesting, nice features in it. But today I want to talk about this live coding demo here at the end of the set of slides. So if you remember last week's slides, we had this design right here towards the end. There was a slide where we asked, how would you generate such a design? And so I want to do that today, first without functions, and then we're going to refactor the code so that it uses functions. But the first thing I want to talk about is how we might go about solving this problem. So this is a lot of lines. That was my first take on this image here. This is a lot of lines, and if we just set about trying to draw each of these lines, we might have a hard time. But when I looked a little closer, I noticed that this is actually a lot of squares. So this line right here comes up, and then there's a line that comes over, and a line that comes down, and then a line that comes back. And they actually tried to point this out with some of the build slides here in the different colors there. So this is just a lot of squares. So it looks like, when I think through how this image might have been generated, maybe first somebody drew this square, and then somebody rotated a little bit and they drew this square, and then they rotated a little bit and they drew this square, and so on. And I think, and we will find out, but I think if you do that all the way around in a circle, then you're going to get this exact figure right here. And there's some number of repetitions. I'm not going to count them all, but we'll just kind of approximate it as we go. We don't have to be exact. This is, nobody's grading us on this. So anyway, the first thing that we've got to do, we've got our PyCharm window here. We've got to prepare to draw a square, right? That's how we broke the problem down. It's a square, rotate, square, rotate, square, rotate, and so on and so forth. So the first thing that you do for that, import turtle. Again, turtle is a module, and we're going to talk about modules further in the class today. But one of the things that module can do is give you a screen. And you want to assign the screen to a variable, right? So screen is a function inside the turtle module, and we're going to run that function with these parentheses here, just like we've done before. We're going to assign the output to the str variable. And then we need to generate a turtle, turtle.turtle. And again, turtle is some kind of function. In this case, it's actually a more specialized thing called a class, which we're going to talk about later on. But essentially what you're doing right here is you're running a function that generates a turtle for you. So this initializes the turtle. Initialize means it sets all the startup values, it sets all the defaults, it gets the turtle ready to draw, and you run that initialization function just by saying capital turtle parentheses. Anyway, so now we got our turtle, we got our screen. The next thing that we're going to need to do is let's set some colors on James. What is it? Pen color. Let's say red here. Red's my favorite color. We don't have to do this, but I like it, and maybe we'll make it do some fancy stuff later. Okay, and now we need to draw a box, a square. So the turtle starts off facing right. So we can just go forward, then go up, then go left, then go down, right? Okay, so you've done this a bunch. Forward, line len. We'll set the line len as a variable, and that way we can change the line len later. 100 is a good value to start with. So forward, line length, James.left. So once James has gone forward, then he needs to turn left 90 degrees so that he can go up. Left 90. And now we basically just want to do these things over and over. So I can paste them real quick like that. That's really ugly though. So I'm going to put him in a for loop here. For line num in range 4. And we've got to make sure that we indent our code. So I indented my code right there underneath the for loop. Okay, so now this is essentially going to run this 4 times, and that should generate a box. And at the end, James will turn left a last time, but he won't move forward. So at the end of this box draw, James will be facing the way he started again, or he should. Let's see what happens. So we want to use exit on click so that we can see what's on the screen at the end. Let's run. Awesome. So James drew the box and he ended up facing exactly where he started. That's exactly what I hoped would happen. Great. Okay, so we draw a box. Let's go back here. So we've drawn this box here, and we're facing to the right. We're facing east. Now we actually need him to turn down a little bit, this angle, and then we need him to draw another box. Okay, so we can do that. We can have him turn, oh, sorry. So normally he's been turning left to go around this box in that way, but now we need him to turn right. We'll have him turn right, James.right. I'll call it twist angle. Now how much is this twist angle? Let's just set a value and see what happens and make sure we know what's going on. Twist angle. We'll figure out how to calculate this later, but 45 degrees, that's a pretty big twist. Let's, great. Okay, so we twisted, but now we need him to draw a box again. And we're going to need him to do this a bunch of times. So I'm going to put this in another loop, range 2. And we're just going to draw 2 boxes for now. And again, I've indented my code. It doesn't do it for me when I've already written the code, so I have to make sure to do that myself. Awesome. So we've got twist angle set to 45, pen color red. Now we're going to draw 2 boxes. The first box, James hasn't twisted at all. He just goes straight and he draws the box just like before. After he's done with those 4 lines, he twists right and he goes back again and he draws another set of lines, another set of boxes. He goes down here, another box. And then when he's all done, he twists again, and you can see that's why he's facing down instead of down and to the right. All right, so this looks pretty good. I think if we kept going, you know, if we got 1, 2, and now he's going to draw a box down, right? And then he's going to draw this one here. 1, 2, 3, 4. I think we could fit 6 boxes like this. Let's find out. Let's see what 6 boxes look like. So that 2 was where we had our number of boxes to draw. So I'm going to replace that with a variable, and I want to make that variable box count. So we'll just replace it with a variable, and now we can just change this number here instead of changing the number down here every time. Make it a little bit more friendly. Oh, yeah, got to stop and rerun. Okay, 1, 2, 3, 4, 5, 6. Look at that. We could have fit in a 7th box, couldn't we have? All right, so let's say box count 7. 1, 2, 3, 4, 5, 6, 7. Oh, we could have fit in an 8th box. Look at that. Could have fit in an 8th box. Now, I don't like waiting for James. So there's a way that you can say speed up, and speed 0 is the fastest. Awesome. 1, 2, basically we got 1, 2, 3, 4, 5, 6, 7, 8 boxes. And you can see if now he's facing right again. So if he redrew a box, he would just be drawing right there. We could tell him to do 16, but he would just, oops, he would just overdraw his old boxes. Yeah, so design didn't change. So 8 is the max. All right, so that's cool, but we want to actually have a lot more boxes than 8. We want to have like 20 boxes or 100 boxes or something in between. I don't know how many that is. I would have to change the twist angle, right? In order to squeeze in more boxes, we have to turn less. Sorry. And then we also have to change box count. I don't really like having to change both of these numbers here. I want to just change one number. You know, I want to say box count. I want to say box count 100, and I want it to figure out twist angle for me, right? I don't want to have to figure it out myself. I don't want to have to guess and check. So we're going to need an equation. Well, I don't know what the equation is. Let's figure it out. Okay, so around this circle, there are 360 degrees, right? And if we want to fit in 8 boxes, so that the last one ends and our guy is facing east the same way he started, we have to fit in 8 boxes into this thing. We've got to essentially divide these 360 degrees by 8. All right, so here's my messy terminal. Let's see, this is maybe hard to see. I apologize if it is, but I'm gonna pull up a little Python 3 terminal here and do some math. So previously we had 360 boxes, we had 8 boxes. And I think if we just divide this 360 degrees by the number of boxes we want, we're going to get the number of degrees we have to have on each twist. And so, you know, my guess before was we had 45-degree twist, and then we figured out that we could fit 8 boxes in. So we see 360 divided by 8 is 45. So that came out just right. So it's that means our equation is going to be 360 divided by the number of boxes we've got. All right, so we want to have box count to be 100, but let's just start with what we know. All right, so we think 360 divided by 8 is going to produce a twist angle of 45, and that's going to get fed in down here and do the exact same thing that we saw before. Indeed, we see the same output, so that's a good sign. Let's just start with like box count 20. so that's getting pretty close to what we hope for in the output of our program here. This has a few more boxes. Let's say box count 40. And now you're really going to be hoping that the speed is fast, because otherwise it would take forever to draw these boxes. Yeah, I think that's pretty close to what we see here. Oh, there's even more there. Let's say box count 100 real quick and see how that looks. I think that's more boxes than he drew on his slide, right? Sorry about that. Sorry. Let me run something real quick on my messy terminal here. All right. Okay, so this is more boxes than he drew here, but that looks pretty good, right? This is exactly what we were hoping to get. We've got this code that produces that. And if you're confused about how we got any part of this, the great part about a video is you can just rewind and see exactly how we did everything, how we got this equation here, and also feel free to shoot me an email if you got any questions. Anyway, what we're really here to talk about is functions, right? So the great, and we've seen functions before, right? We've used functions. Here we're using a function. Here we're using a function. These are both functions. They're functions on classes, but they're still functions. Pen color and speed. Range is a function. Forward and left and right are functions, right? The great thing about functions is that they take some of the code that we would normally put on a line here, and they put it somewhere else, right? So we don't have to do the work to turn James left on this line. We can just say James.left and tell how much we want to turn left. So functions take the code and they put it somewhere else, and that's really nice because it makes our code more readable. You know, if we had to do all of the individual steps to turn James left, I don't know what they are, but it's ugly, right? Because it's drawing on a screen, like it's got to tell your monitor where to put red dots and things like that. That's all inside of this left thing here. If we had to do all that work, then it would be really confusing what our code is doing. But here, we can see our code is very simple. James move forward, James turn left. Do that 4 times, and then turn right a little bit, and then do it box count times. The great part about functions is that they abstract. That's what we call this, abstraction. They abstract away complexity. So let's abstract away some complexity here. This chunk of code right here tells James to draw a box. And it's pretty simple. It says, you know, go around 4 times, move forward, turn left. 4 times in a row. That's pretty simple, but we can make it really simpler. What if we could say something like, draw a box, James? Right? What if we could say that? Now it's pretty clear exactly what we want from James. We want him to draw a box. PyCharm doesn't know what we're talking about yet, right? It doesn't know what draw box is because draw box is not a thing. So we're going to make it a thing in just a second. The other thing that we're going to need to say when we tell how to draw a box, when we tell James to draw a box, is how big of a box. Right? So we're going to also want to give James, you know, the length of each line when he's drawing a box. All right, so here's my wish. My wish is that I could just write this line here and Python would know what I'm talking about. But right now it has no idea what I'm talking about. Draw a box is not defined. Now the way we can define it, we'll go up here before we use this function. We're going to go up here and we're going to define it. Draw box. Tert len line len colon. All right, so this is the smallest version of that function that we could define. We've got this 3-letter statement here, def, that stands for define. We've got the function name, drawBox, just like we had down here. We're going to pass in, this is a parameter, just like red or 0 or line len or 90. We're going to pass in our turtle. Now I don't have to name him the same thing up here. I can just name him Turt. I could name him Sammy. I could name him the same thing. I could name him James, but I don't have to. I'm just going to call him Turt, right? And that's mostly to demonstrate to you that the name inside the function doesn't matter. We pass in James. He got renamed up here to just Turt. And then line len. Line len is really, it makes a lot of sense to just name it that. So I'm just going to name it that. Awesome. Now I put this pass here because this tells Python to just pass this line and do nothing. If I just left this line blank, that would be like a syntax error, an indentation error, which is a type of syntax error basically. Indentation error can't have that. But if I just put pass right here, Python is going to do everything. It's going to draw our boxes again, right? We've still got all this drawBox code down here. So this function call is just doing nothing right now. It's just passing to the next line. Anyway, let's stop that being the case. Let's take our box drawing code. I'm going to just cut those lines. And I'm going to paste them in up here. Control-C and Control-V works on your computer. And now I don't need that pass statement anymore, so I got rid of it. Awesome. Now the only thing is my turtle is not named James up here. My turtle is named Turt. So make sure that you fix those things up if you are doing what I'm doing and refactoring your code. And now you've got line len. Let's see. Oh, Shadow's name line len from outer scope. That's okay though. Awesome. So, okay, so now we've got our drawBox code. This tells whoever Turt is to move forward, you know, line length, turn left 90, and then do it again and again and again. And now down here, we just need to say drawBox James line length. And he's gonna, then once Python starts to execute this line, it's gonna jump up here, and instead it's gonna do this stuff. Let's slow the speed down a little bit. Oh, sorry. So we can see he's drawing these boxes. Right here, he's back at the start point. He's right at the beginning of this line again, right? And then he twists. He makes this twist angle, and then he comes back up again and he starts to draw a box. You can see he's just drawing the box. He's executing this code up here. Twist, move forward, turn left, move forward, turn left, so and so. Awesome. We're not going to wait for that to finish. That's going to take forever. Okay, so now we've abstracted some functionality up here into drawing a box, and that's great. We could pass in a different line length, and this would just automatically know how to draw a box of the right line length. What else can we abstract out here? There's not a lot of repeated code in here. You know, this for loop does the repetition for us every time. I guess we could take out some of this stuff right here. This is you know, this twist angle. This is calculation plus these statements down here. It'd be nice if we could just say, you know, draw cool circle, you know, draw a funky circle. You know, it'd be nice if we could just do like draw a funky circle. James, right? Hey James, do that funky thing you do, right? Now we do have this awesome parameter here, box count. It'd be nice to tell James like how many boxes we want in our funky circle, And it'd be nice to tell him, you know, how long we want the lines to be. But then if we could just say that and have James draw the funky circle, that'd be awesome. And so the code then that we need to move out is this stuff right here, right? So we want to make a function called draw funky circle. Def draw funky circle. We'll call him Turt again up here, but we can call him whatever we want. We got box count and line len. Awesome. We can call these whatever we want. I'll call them BCNT and L len, just to demonstrate that we can call them whatever we want. Okay, now we could put pass up there, but we'll just cut this code out. We want to cut out those 4 lines and paste them up here. And it even did the indentation automatically for me. That was nice. Okay, so now when we tell James to draw a funky circle, we'll tell him the number of boxes we want, and we'll tell him how long we want the lines to be. And then he'll jump up here and he'll calculate the twist angle. Then he'll draw each of those boxes in turn. And he's going to use this drawBox function to do it, right? I mean, we've already written this drawBox function, so this function, draw funky circle, is going to call, that's what we call it, calling. Draw funky circle is going to call drawBox a bunch of times to draw those boxes. Okay, now that's pretty slick. So we wrote these functions up here. Each of these is pretty simple. This one draws a box, this one draws a bunch of boxes. And now our main code looks like this, right? We set the length of a line, we set a box count, we set a pen color, and then we set a speed, and then we draw a funky circle, and then we exit on click. So this makes our code a lot simpler, right? Now this is really the code that you got to read. Draw a funky circle. Let's see if it works. Oh, that's too slow. I'd like to get done sometime before an hour today. We're going to go for like five or 6 more minutes here, guys. I'm sorry this is taking so long. Anyway, we can see James draws the funky circle, no problem. So that demonstrates that we've successfully abstracted out code into this spot above. Now I'd like to do something else. I think it would be really cool if the pen color changed, right? Like so the Chiefs won last night, so it's like red, yellow. We could say white, but then we need to change the background. What is it? Screen.background color. How do you set the background? Oh, there it is. Black. I think that'll work. All right, so here's the different colors that I want the pen to be. And I want it to be different colors on different boxes, right? I mean, look at this. This is just for the slide, but look at this. They drew some of these lines in kind of different colors there. So I want that for our James, right? Our James is cool. I like him. That means that I want to change the pen color between boxes, right? So up here, this is where we drew the boxes, right? I mean, this draws the box, but this tells James to draw a box. So if we want to change the pen color, we got to do it right before this line. We got to do it like right here. You know, right in here, this is where we got to set the pen color. And so that means I think I just need to move this code up into here, right? So first of all, that little list right there, it's not doing anything yet, right? I just wrote them down. So we need to change the pen color in here. And we could say this, and that will every time set the pen color to the 0th color, which is red in this case. Which looks flippin' sweet if I do say so myself. But we actually want the pen color to change. So one time I want it to be red, then yellow, then white. Now we can do this with modular division. So if you forgot what that is, then you can look back a little bit. But what we're going to do is we're going to do this. All right, that's a pretty wonky little statement there for me to just put down on the screen without walking you through. So I'm going to walk you through it right here. So we're going to say colors, box num. Now I'm not going to run this code. I'm just writing it here so that we can talk about it. Don't worry. All right, so this was our statement up here. So these brackets are going to they're going to cause Python to look up in this colors list an index, right? So before we had colors 0, and that pulled out red. And if we said colors 1, that would pull out yellow, and colors 2, that would pull out white. And if we say colors 3, Python's not going to know what we're talking about. There is no colors 3. That would be right here. So modular division is remainder division. So modular division looks like this. If you say 0 divided by 3, in this case, because len colors is the number of items in color, so 3. So this is 3. So if you say 0 divided by 3, that equals 0, right? We're not dividing by 0, we're dividing by 3, so it's not an error. 0 divided by 3 is 0. 1 divided by 3 is 0. 2 divided by 3 is 0. 3 divided by 3 is 1. 4 divided by 3, 1. And 5 divided by 3 is 1. That's how integer division works, excuse me. We're in Python, so I should have had, this should be integer divisions, right? 0 divided by 3, 1, 2. 3 divided by 3 is 1, 4 divided by 3 is... But each of these has a remainder, right? Remainder is 0. Remainder here is 1. Remainder here is 2. 0, 1, 2. 3 divided by 3 equals 1 with a remainder of 0. 4 divided by 3 equals 1 with a remainder of 1. 5 divided by 3 equals 1 with a remainder of 2. Now this pattern, 0, 1, 2, 0, 1, 2, 0, 1, that'll continue forever. So, 6, remainder 0. 7, remainder 1. 8, remainder 2. 9 divided by 3, remainder 0. 10 divided by 3 has a remainder of 1. And so I can use this, this pattern 0, 1, 2, 0, 1, 2. We hope our first box will be drawn with index 0, red. We hope the next box will be drawn with index 1, yellow. And then we hope it'll be drawn with index 2, white. And then we want it to go back to the beginning again. Index 0, red. Index 1, yellow. Index 2, white. So box, the first box, the 0th box will be red. The first box, yellow, white, red, yellow, white for the 5th box here. If we could calculate the remainder, and we can do that by saying, again, remainder division, modulus division, 0 mod 3, the mod, this percentage produces the remainder. So 1 mod 3 equals 1, 2 mod 3 equals 2, 3 mod 3, that's going to produce the remainder of 3 divided by 3, which is 0. 4 mod 3 is going to produce the remainder of 4 divided by 3. The remainder is 1. 5 mod 3. So that's how modulus works. So here I've said box num. Box num is this thing that counts. Every box gets, box 0, then 1, then 2, then 3, then 4, then 5, because of this range here and the for loop. So this is going to steadily increase. Then we're going to mod it by the number of colors that we've got, which is 3. So we're going to get exactly this output here, 0, 1, 2, 0, 1. And then each of those is going to get looked up in colors and fed into pen color. So that means our first box will be red, then yellow, then white. Sorry, our 0th box, because we start counting with 0. Our 0th box will be red. Box number 1 will be yellow, then white, and so on. Let's see what we get. Excellent. Every box has a different color. That actually looks pretty awesome, I think. That's pretty cool. Awesome. So now our code does all of that stuff there, and all we needed to do was run this function right here. We say draw funky circle with James, the box count, and the line length. Now we could abstract this more. We could say, we could have even another function here, def do a drawing, and we don't even really need to send it anything. We could put in our function all of this stuff right here, right? We could take all of this stuff. Oh, sorry. We could paste it up underneath do a drawing. Okay, now do a drawing is a function that does all of our drawing stuff. And now all we have to say down here is do a drawing. Okay, so all of the rest of our code now is embedded, except for import. That should be at the beginning of a program always, and not indented, not in a function or anything like that, just import turtle. But other than that, we've got all of our code in functions, and all of these functions call other functions. And then all we need to do outside at the bottom is do a drawing. Box count is not defined. I don't think that's true. Oh, wow. That was a bug from earlier that we were lucky to get away with. And we're actually going to talk about the reason why we were able to get away with these bad names later. I'm sorry if that caused any confusion. You should all be named like this, because they got renamed inside of here. Awesome. He draws the box. He does the drawing. Okay, so I'm sorry that went longer than I expected. I guess I'm glad I made a separate video about it. We had plenty of time to talk through it, and I could bore you to death. Let's hope this recording works. Anyway, I'll see you guys on Wednesday. Sorry I couldn't be there today, and I hope you're enjoying your hot chocolate.